In this lecture, we're going to start getting into the nitty-gritty and the details of R. In particular, I'm going to talk about different data types that are used in R and some basic operations on those data types. So first, it's important to kind of get the language right correctly. So all the things that you manipulate in R, all things that we encounter in R, are what might be called objects. Objects can be all different kinds, can contain all different kinds of data, but everything in R is an object. So the R has 5 basic atomic classes of objects. So these are kind of the very low level or basic classes of objects. And they are character, numeric, so these are like real numbers or decimal numbers, integers, complex numbers, and logical. So logicals are just true-false type things. And so the most basic object in R is what's called a vector. And a vector can contain multiple copies of, for example, of a single type of object. So you can have a vector of characters or a vector of integers. One thing you cannot do with a standard vector is have mixed types of objects. So you cannot have a vector of characters and numerics, or numerics and integers, or integers and logicals. Everything in a vector has to be of the same class. Of course, with any great rule, there's always an exception, and this one is no exception. So with vectors, there's one type of vector that can have multiple different types of classes, and that's called a list. So a list is represented as a vector, so it's a sequence of objects, but each element of that vector can be can be an object of a different class. So for example, you can have a list that has a character, it has a numeric, it has a logical. You can have a list that's inside the list. One element of the list can be a data frame. So any element of the list can be anything. And that's actually what makes the list so useful. So the list is one exception to the general rule that vectors can only contain elements of the same class. So you can create an empty vector with the vector function. And the vector function has 2 basic arguments. The first argument is the class of the object, so the type of object that you want to have in the vector. And the second argument is the length of the vector itself. Perhaps the most important type of object in R, of course, is the number. So numbers in R are generally treated as what are called numeric objects. So pretty much all numbers are treated as double precision real numbers. So even if you're looking at a number that's like 1 or 2, R thinks of those numbers as numeric objects. There is a way to explicitly say you want an integer, and you can specify the capital L suffix there. So for example, if you just enter the number 1 in R, that gives you a numeric object, but entering 1 with a capital L next to it explicitly gives you an integer. This distinction is not very important right now, but it will become important later. There's also a special number called inf, which stands for infinity. And inf is like a real number. It can be used in calculations, and you'll get the expected results. So, for example, if you take 1 and divide it by 0, you'll get infinity. And if you take 1 and divide it by infinity, you'll get 0. So, inf is a special number, and you can also have minus infinity, too. There's another special value called nan, or nan, and this represents an undefined value, so you can think of it as not a number. So, for example, if you take 0 over 0, that's not a number, it's not defined, so you'll get a nan back. Nan can also be thought of as a missing value, but we'll talk a little bit more about missing values a little bit later. So, another thing that comes with each object in R is an attribute. So not every object in R necessarily has attributes, but attributes can be part of an object in R. Some of the most common types of attributes that we'll encounter are names, or dim names, or for dimension names. Dimensions, so a matrix will have dimensions. For example, it'll have a number of rows and a number of columns. If you have a multidimensional array, you'll have more than 2 dimensions. The class of the object, so every object will have a class. So for example, numeric objects, their class is numeric, and integer objects, their class is integer. Every object also has a length. So for a vector, it's quite simple. The length of the object is just the number of elements in the vector. And then there may be other user-defined attributes or metadata, so these are things that you can define separately for an object using various attribute functions. There is a general function called attributes, which allows you to set or modify the attributes for an R object. So once we start typing things into the R prompt, then we're going to start coding and doing calculation. So the things that we type into the R prompt are called expressions. So for example, the symbol which looks like a left-hand arrow and is actually the less than symbol followed by a hyphen, this is what's called the assignment operator. The assignment operator is what assigns a value to a symbol. So for example, in this first expression here, the symbol that I'm creating is called x, and the value that I'm assigning it is 1. And I use the assignment operator to create that. So x is 1 is an R expression. And the next expression, I'm going to print that value. So print is a function, and I'm passing it the symbol x. So when I print out x, I get its value, which in this case is 1. So another thing to think about is x is also considered is an R object that is a numeric object that has one element. So it's really a numeric vector where the first element is the number 1. In the third expression here, you'll notice I'm just typing x at the prompt, and when you hit enter, what happens is it prints out the value of x. So this is called, this is another way to print out an object without explicitly calling the print function. So in this expression over here, I'm creating a new symbol called message, MSG, and I'm assigning it a value of the string hello. All right, so now this is a character vector, and the first element of this character vector is the string hello. I could add other elements to this vector if I wanted to, but they would all have to be character. So the grammar of the language determines whether an expression is syntactically correct or not, or whether it's complete. So for example, if I just type x followed by the assignment operator and I don't type anything else, that's not a complete expression. And so when I hit enter, nothing will happen because it's waiting for the expression to be completed. The other thing I've got here is this hash symbol here. So this hash symbol here it indicates that everything to the right of that is a comment. And so the R engine will ignore anything that happens to the right of that symbol. So you can put things like comments or notes to yourself in code, and R will just ignore those comments. So once you've typed in a syntactically valid and complete expression at the prompt, when you hit enter, what happens is that the expression is evaluated by the R engine. And the result of that evaluated expression is then returned. And so sometimes when you evaluate an expression, nothing happens because there's nothing to really show. And so for example, in the first expression here, when I say x is assigned to be 5, so I'm creating an object called x. It's a numeric vector, and the first element is going to be 5. Now when I hit enter, nothing happens because there's really nothing to show. But now when I hit x and I hit enter, it prints out the value 5. So it prints out the value of x. So when I hit x, when I type in x and I hit enter, and it prints out 5, that's called auto printing. And so when you just type an object's name and hit enter, R will by default auto print the value of that object. This is the same as calling the print function on that object, which will just print out the value of that object. So you can explicitly print an object, or you can auto print an object. So this sounds a little complicated, but it's really just the natural thing to do. And it's what most people would expect. You'll notice that when I print out the object x, there's a little 1 in brackets here. And you might be wondering what that is. So all that indicates is that it's telling you what element of the vector is being shown. And this will make more sense when we have longer vectors to look at. But all this is saying is that the number 5 that you're seeing there is the first element of the vector. So for printing, you'll see that here I'm creating an object called x, and it's the sequence 1 to 20. So the colon operator here that I've used is what's used to create a sequence. So when I say 1:20, that creates a sequence of 1, 2, 3, all the way up to 20. So now when I auto print x in this case, you'll see I've got a much longer vector here. In this case, this is an integer vector. And you'll see that the first line of the printout has a 1 next to it because that's the first element, and then the second line has a 16 in brackets because that's the first element of that line is the 16th element of this vector. So it's all kind of straightforward, but just that's how the printout works.